So you're probably out there thinking, dude, we just did spermatogenesis. How hard can oogenesis be? And I'd like to just take a minute to caution you because spermatogenesis is a very straightforward process. If you understand meiosis, then you are totally good to go for how sperm are made. And if we think for just a second and have a little perspective here on the fellas, every single ejaculation, every single like sperm delivery goop contains 200 to 500 million sperm. What? 200 to 500 million sperm are in every single ejaculation. And if you think about how often someone ejaculates, that's an incredible number of sperm. Now, the ladies, we have 500,000 possible eggs in our ovaries at any given time, 500,000 total. And every month after puberty, we make one. We make one egg that might possibly be fertilized. And are you ready for this fast fact? Unless it gets fertilized, it doesn't finish meiosis. So truly, you can think back on how many times you've been pregnant in your life. How many fertilized eggs? Now, granted, there are probably some eggs that got fertilized that you didn't even know about because they just went the way of genetic issues and you didn't even know you were pregnant. But assuming all the known pregnancies are the ones that you, that's it, that's all that happened, that's how many times your eggs have completed the process of meiosis, which really is not, even for people who have like 12 kids, that's 12 times that you've gone through meiosis and completed it, as opposed to the fellas 200 to 500 million times completing meiosis for every single ejaculation they go through. I mean, the difference is profound. So I just tell you all of that to get you mentally prepared for the fact that it's going to be different here. I'm going to draw you a very large picture that's going to have a lot of information on it. And the reason why I'm doing this is because I want us to be keeping track of two things. I want to keep track of oogenesis. And that's the actual process of egg making. And we can just go ahead and start this thing by remembering or applying what we already know of spermatogenesis and going, okay, probably we're going to have a diploid cell called an oogonium. That's easy. That's probably going to go through mitosis to produce a primary oocyte. And the primary oocyte, as we, like, I mean, it would make sense, right, that it is also diploid. So it has, it's just the product of mitosis, just like with spermatogenesis. The difference is that our primary oocytes that are all present in our ovaries, all 500,000 of them, are present in our ovaries before we even are born. So this is all happening before you even come out of your mama's belly. And in fact, at this point, this is the other thing that I want to keep track of. At this point in the game, all of our oocytes, so this is before you even come out. This is in mama's belly. This is in utero. That says utero. You end up with everybody who is almost ready, and they actually start the process of meiosis, and they get stuck in prophase 1. Did you follow what I just said? And this is all in utero. So your 500,000 oogonia go through mitosis and become 500,000 primary oocytes, and the primary oocytes start the process of meiosis, and they get stuck in prophase 1. They live in follicles. And every month, your follicles change, and once you've gone through puberty. So the follicles that they live in, and so I'm going to draw a picture of my primary oocyte, and I'm going to try to keep the colors consistent for you. The primary oocyte is diploid, so you're cool with this. This is my primary oocyte, and it lives in a primordial follicle. And I'm drawing it for you. The primordial follicle is identified by these squamous cells. It's not squamous epithelium. It's just a single layer of flattened cells. You know it's not epithelium because it's not lining a space. It's just surrounding the oocyte. And so the oocyte is living inside this primordial follicle. And I'm going to look, primordial follicle. And the little green cells are just flat little cells, but they're going to give rise to someone else once we go through puberty. Before you even come out, all your primary oocytes are living in primordial follicles. Now you come out. You do your thing for about 13 years or however long it takes before you start to become reproductively mature, which is terrifying. At that point in the game, every single month, your body prepares one oocyte, one. And you're only going to finish meiosis if that one gets fertilized. So most of the time, especially when you're 13, you're not going to finish meiosis like this, but your follicles are going to start changing. And why do they change? Because holy hormone cocktail. Let's just make a note that we're now in puberty. And so puberty, as soon as it starts, you start getting crazy hormones. We'll talk about those in physio. And the hormones are going to cause these primordial follicles to change. However, what kind of cell is still living inside of my primordial follicle that's about to become somebody else? Still a primary oocyte. See my color coding? All right. So my primary oocyte is now my primordial follicle cells, they get bigger. They turn sort of cuboidal. And this is a cycle. And so when you see them turning big like this, now they're called granulosa cells. And this is a primary follicle. I'm going to try to fit a lot of stuff on here, which is why I'm drawing them so small. So why did this happen? And how many of them turn into primary follicles? About 20 of them. So out of your 500,000 in an ovary, about 20 of them are stimulated to become primary follicles. The rest of them stay primordials. And it's hormones that do this. Okay. Some of these, not all of them, are going to be stimulated to become what, do you think? Secondary follicles. And there's some things that happen in order to do this. But guess what? Tell me, like, go ahead and guess, because I'm getting all excited. What do you think is true about it looks like the color changed, but it didn't. My oocyte is still a primary oocyte, which means it's still stuck in prophase 1. But things are changing around it. My granulosa cells are actually multiplying. And so I'm going to try drawing this, still showing you a layer of granulosa cells that directly surround my oocyte, because now we're going to give those guys a name. But I'm also I'm definitely growing more and more and more granulosa cells. And the granulosa cells are producing fluid. So look at how I'm drawing these guys. I'm just showing you that these are all granulosa cells. But do you notice that space in there? The granulosa cells make fluid, and that fluid gets dumped into this space. And I'm going to draw the fluid going into the space because that's what they're producing. And you can imagine that as they get bigger and there's more of them, they produce more and more fluid, and the fluid forms a space called the antrum. That's the antrum right there. All right, I still have my primary oocyte inside. There's more cells, and I have to draw these guys in here too, and they actually are in my primary follicle as well, and they're called thecal cells, and they're flatter, and they look more, they look messier. So these are thecal cells. And they are also still surrounding my secondary follicle. So the secondary follicle ends up having some really interesting characteristics, primarily that space in there, that antrum. In fact, that antrum is going to define the difference between a primary follicle and a secondary follicle, keeping in mind that we're going to increase our layers of granulosa cells all along here. Now, there's somebody else that I didn't draw yet, and this is another person who is going to show up at some stage in this game. Somewhere you actually can find this structure in the primary follicle, and it's usually definitely there by the time the secondary follicle comes in, and this is called zona pellucida. I think of zona pellucida as like a clear area surrounding the oocyte. And it's like it's made of glycoprotein stuff, and it looks like a line surrounding the oocyte itself. In addition to that, the layers of cells, the layers of granulosa cells that are the single layer of granulosa cells that are surrounding the oocyte itself, this layer of granulosa cells is called the corona radiata. So the zona pellucida is thin, surrounding my primary oocyte. The first layer of granulosa cells is the corona radiata. The antrum is this big space, and all that stuff makes up the primary or the secondary follicle. And dudes, it still has the secondary oocyte in it. I mean the primary oocyte in it. Crazy talk. Now, one follicle is going to finish this job and is going to turn from a, okay, we're going to make this follicle or this oocyte. The oocyte inside one follicle is going to continue on the meiotic process and enter meiosis 2, and it's going to get frozen in metaphase 2, which means the cell itself is now haploid, and it had to make another guy, right? It had to make another little cell, and I'm going to tell you what this thing is. It makes just a little blob of DNA. It doesn't even become a cell. It's like we've got extra DNA, let's get rid of it, and all the cytoplasm, all the good stuff stays with that original, what is now a secondary oocyte. That thing is called a polar body, and it's garbage. it gets thrown away. And this guy gets kept, and this is a secondary oocyte. Secondary oocyte is what you're going to find in the mature follicle. So I'm going to let you know that we're going to talk mature follicle here. And my secondary oocyte is going to be in my mature follicle, but as you know, unless it gets fertilized, we're not going to finish meiosis. So let's look at the structure of a mature follicle. Now my ovum, my oocyte, is different looking. It's a different color, but it's haploid now. And we still have zona pellucida surrounding the whole thing. Oh, geez. You're cool with this, right? We still have corona radiata. So corona radiata is that first layer of granulosa cells. And we now have wholly giant, now I'm not going to be able to draw it as giant as it actually is, but these are all my granulosa cells, and I'm not kidding you, like it's huge. And it's like that huge, like whoa, holy huge. And they're still surrounded by thecal cells. So this whole thing is surrounded by thecal cells, and it's gigantic. What? We still have our antrum, and our antrum is growing. Secondary oocyte inside this huge mature follicle. Gigantic numbers of granulosa cells all producing fluid. All that fluid is still coming in here. The pressure is increasing. The tension grows. What's going to happen next? We'll look at the thing that we're going to talk about next for a hint as to what our next topic will be. Goodbye.